So I'm Zeynep Engin. I basically organize these conferences for the past 5 years now. This is the first time we are trying the pre-conference workshops. We introduced this a little bit late as well. So I think that partially explains why we are so few people, too few people maybe in the room, but we wanted to go ahead in any case. So basically my colleague Adriano and I have been working on issues around mainly algorithm assessment, but more generally we are developing an agenda at UCL around digital ethics as a whole. So in the first part, basically I'll try to give you an overview of how we see the landscape of digital ethics, and we'll try to zoom in towards how we think the algorithm assessment should happen as well. And then after the break, Adriano is going to give a more detailed presentation on various aspects of assessing an algorithm. So in the first part, I will just give some overall introduction about what we mean by digital revolution. Then I'll try to go through some of the hype words, the big words, big data, artificial intelligence, blockchain, etc. And we'll try to just very briefly introduce them and mention some of the issues, some of the contested issues about those technologies. And then I'll go into some definitions, digital ethics, data, algorithms, and interactions. We'll then give a series of case studies on really interesting case studies are emerging, almost like as textbook cases that we want to go through as well. And then I'll briefly introduce a set of building blocks that we think should be part of an algorithm assessment framework. So first of all, digital revolution, everything is changing. We have machines that are able to learn from data directly and give us some human-like insights. We have got lots of data coming from everywhere in all sorts of types and letting us come up with really interesting insights about behavior of customers or predict the future. We have got more structured data through Internet of Things. It's again everyday items with an on and off switch can have the capacity to basically provide us more data to work with. And finally, the blockchain, really how we are organizing trust in this age of at this age and at this time. So this is, well, since it's Data for Policy conference, I wanted to first show this table. I know it's a big one, but basically this is a taxonomy of different government functions that Philip Trilevan here at UCL and myself has brought together, and this has been recently published in the Computer Journal. Basically, we thought that if we were to look at government as a whole, what would be the functions that we could change, we could disrupt in a way with the technologies that are available, and it really ranges from all the way from public services to how we deliver justice, how justice is delivered, or how we deal with national physical infrastructure, or how we deal with national public records as well. We can support obviously civil servants. We can provide them better evidence. We can formulate policies better by monitoring basically public opinion a little bit better, and also simulating potential scenarios better as well. So we think there are really lots of potentials here to start with at this stage even. So they're all really exciting, they're all really interesting as well. So we basically, this is a phrase that I have adapted from somewhere else actually. So it's really the future. We are living in the future, but it is just not fair, safe, legal, and transparent enough yet at this stage, and that's the problem that we are trying to deal with. And here is a nice, I think, illustration of how public sees, how public perceives this. We have got fears around, again, all the way starting from we are going to lose our jobs to well, our existence is under threat, and machines will take over someday. So this is just supposed to be a quick joke. And in another recent sort of working paper, we have tried to summarize a range of different problems that we thought would fall into this area. So it again starts with our democratic processes, how we basically deal our representation, what we think about our freedom of speech, censorship, how we do have alternative concepts of democracy, like in the case of liquid democracies, e-voting schemes, etc. We are talking a lot about citizen rights, ownership, who owns our data, who controls that data. Does all these changes bring us more fairness, or how do we ensure fairness with respect as a side sort of thing, along with personalization of services and personalization of the view, actually world view. We have got lots of economic issues that we are discussing, especially in terms of the taxation of digital services. For example, with blockchain, we have started talking about cryptocurrencies and things like sharing economies, etc. Our psychology, perceptions of the world is changing. Our perception of privacy has certainly changed over social media, especially. What we are seeing is through search engines, or again personalized services, our worlds are becoming smaller and smaller as well. In a way, our perceptions are skewed. We are talking a lot about security for obvious reasons. We are talking about legal status of algorithms creating agency themselves and therefore becoming almost like artificial persons. With the Bitcoin debate in particular, we have come to realize that actually these sort of highly complex computations has an environmental cost to it as well. And I mentioned the job losses and other social considerations earlier as well. But from my point of view, and the stance that I take, really, yes, all these exciting developments are happening, but how does it help us to create? I mean, not just like being reactive to those technologies, but can we actually proactively try to make use of these technologies to create a better world, to create a fairer world and more ethical world than humans? That obviously is a high ambition, I guess, and we need to really ask, to be able to ask that sort of a question, we need to ask to what extent really concepts such as fairness or ethics can be formulated mathematically, programmed and embedded into computing systems. And you have to also remember that these are the terms that change as well. They are very dynamic terms, depends on time, demographic viewpoint, and many other factors. So in terms of the technologies, the artificial intelligence, clearly. So when we talk about artificial intelligence, I'm using it as a very broad term, just to sort of to denote anything that all of the algorithms, all of the systems that show human-like behavior, human-like insights into interesting problems. So broadly, we have that knowledge-based systems and machine learning type of algorithms. Basically, before that, I should actually mention this little diagram where I'm trying to basically describe what traditional programming was, where we were basically putting all the data and we were a human programmer were coding, and then computer would basically give us some output to work with. In machine learning, what has happened is this paradigm has changed a little bit. So we are now providing the machine, the computer, the data, yes, also the outputs of previous analysis or previous outputs, and then we are expecting the computer to come up with a program for us to use, potentially feedback into. So if we have this program, then the idea is that we would feed into the traditional sort of way of programming and then get more insights as a result of that. So there are obviously issues there. Well, first of all, in the first one, in traditional programming, apart from the efficiency itself, there were lots of problems because of just the design parameters of the programmer themselves, which is also sort of replicated almost in the knowledge-based systems type of architectures as well, where again the designers' assumptions and parameters that they set, and also the conclusions, so the conclusions that they come up with, which are generally discrete. There are lots of problems basically there to think about, and in the machine learning case, the clear issue is dependency of data, because data really becomes the explanation itself rather than, because you don't have a sort of reasoning that you are providing into the machine. And obviously the program that it comes up with is black box mostly. It's not easy for us to get insight. So in the big data case, in big data analytics, again, we say that it's analyzing. We have got lots of data coming from everywhere, and we do have the capacity to analyze these large data sets and come up with interesting insights as a result. There are a whole set of different associated sort of technological challenges, but the most probably in terms of the contested issues, what we see is the quality of data, especially, is a big issue for us to basically limit the use of these technologies. The quality, representation, and structural issues with the data, obviously, and the big debate about whether our analysis should be based on correlation or causation. Also, there are challenges regarding the stream, the analysis of streaming data as well. With the Internet of Things, this time we have everyday items becoming data generators almost. The interesting thing is probably the ability to do some analytics closer to the source of data. In this case, edge analysis cases, for example. Having everyday items producing data obviously brings concerns about constant surveillance. We are also talking about machines interacting with other machines and with potential real-life consequences. So lots of questions again to ask there. And if you process, the advantage of processing at the source also comes with the issue of losing some information at the source as well, which can again create issues in subsequent stages. With blockchain, distributed ledger technologies and smart contracts, general knowledge again, we have, the idea is actually quite simple. So in a centralized, currently most of our systems are centralized, and which means basically different stakeholders rely on a third party as a trusted body to manage the transactions between different stakeholders. And in the distributed ledger technologies, basically the aim, the ideal is that we will not need this central a trusted third party anymore. It will be all the stakeholders will have a copy of all the transactions synchronized all at once and protected as well. So that is the idea. It's a powerful one. Obviously, it basically underpins the digital currencies. In the first place, with the smart contracts, especially, we are talking about possibility of turning rules and contracts into machine executable programs, and being basically applied directly, automatically. Again, although the claim is that it will be those transactions are quite trusted and secure, there is actually possibility of identification for the sensitive data. So that's a big vulnerability, for example, in the situation. And in the European General Data Protection Regulation, for example, we have concepts such as right to rectification of information, things like that. So the owner actually should, I mean, if they wish, they should, the information about them should be changed. But in this sort of situation, for example, there is this immutability to change parameter that is potentially basically contradicting with that sort of requirement. Regulation of these technologies is still not clear at all. And again, I mentioned the environmental issues. Like in the Bitcoin case, we saw that it was causing lots of electricity usage, therefore causing some environmental damage as a result. So a big response, well, a disciplinary response to some of these challenges is what we call information security, where we try to basically ensure integrity, confidentiality, and availability of information. Well, against any type of things which may range from cyber attacks all the way to any computer malfunction or any physical theft, etc. In this case, well, the sensitive thing is really becomes what are the acceptable countermeasures? So what are we trying to protect, and how does it affect the innovation, for example, as a result? Or how do we decide who has access to our data? For example, should it be privileged? Like, should government have more sort of priority to see all this data? Or if it's going to be distributed, then how do we manage that process? How do we decide that? Okay, so that brings me to the next topic, digital ethics. Basically, here we think that, especially again with the European General Data Protection Regulation (GDPR), we have had very sort of healthy discussion over the past few years around the data issues around data. We see more and more studies and more interest on algorithms and how we would deal with some. I mean, we are realizing more issues with them. We are recognizing them, and we are developing frameworks on how we would try to address those issues. Interactions are mostly, we see it in the news items at this stage. We see driverless car, for example, in test situations causing crash, or serious Alexas of everyday life, like doing interesting things. But it's not yet a properly analyzed as much as the other two, probably. So the way that we define data ethics, so ethics in general, we are saying that it's ensuring moral and legal conduct in exploitation and utilization of data and information related to individuals, systems, assets, and all this data for used for both private and public purposes. So the examples that I have, the obvious one, Cambridge Analytica and Facebook case, as an illustration of a multinationals case, basically. And then in the middle, I have got China example, which some people call Big Brother state. It's turning into a Big Brother state because of the amount of citizen data that government has access to, and the way that they use it. We also have this often overlooked problem, probably, this little brothers issue, where the idea is basically one individual or small groups of people being able to access lots of interesting, sensitive data and potentially causing big harm. In the algorithm ethics, again, the idea is that algorithms are becoming more and more like artificial persons, and their potential unethical and illegal decisions are affecting humans. So we have to find a way to ensure moral and legal conduct there. We have important life events like loan applications, sentencing decisions, hiring decisions, etc. So these are all we currently have algorithms in use in a serious situations. In the middle, I have basically I have a stereotype of Google Translate as an example. So what is happening if you can't read it? Basically, what happens is we have two sentences. He is a babysitter and she is a doctor. These two sentences are translated into a gender-neutral language. In this case, it's Turkish, and in Turkish, both he and she translate to the same word, actually, same letter, actually, O. And when you take the exact same phrases and translate back them to English, what you see is Google Translate actually assumes that the babysitter should be a she and the doctor should be a he. So that's how it prefers, basically. And the third example is really a very nasty one. I'm ashamed to put it up here, but I think for educational purposes it has to be there. We have to recognize the seriousness of the situation. It's again Google basically tagging various images quite correctly, but basically to people in a quite racist way, very obviously racist way. So in interaction ethics, the idea for us is again to ensure moral and legal conduct in all types of interactions between data systems and humans. The examples I have is China's facial recognition glasses that police uses. Basically, police on the streets walks around, and for any person that they identify, basically they are able to reach all types of information from their central database in real time and act accordingly. In the middle, I have got social robots. So robots being almost potentially caretakers or babysitters, or if we don't go up until that point, at this stage we have got personal assistants, Siris and Amazons and etc. at this stage. And in the last example that I have is this addictive algorithms problem. That is actually we see that some applications, like especially social media, online gaming or shopping type of applications, they do exploit the rules of psychology to basically make customers, to make us return back to their platforms. And there are sort of interesting consequences as a result. I actually, at this stage, I've got two videos. I hope they will work. I would really sort of invite you to think along with these videos in terms of what might be ethical consequences.
This is your car. This is your toothbrush. These are your things. But these are the things that matter. And somewhere in between is this guy. Introducing Jibo, the world's first family robot. Say hi, Jibo.
Hi, Jibo.
Jibo helps everyone out throughout their day. He's the world's best cameraman. By intelligently tracking the action around him, he can independently take video and photos, so that you can put down your camera and be a part of the scene.
Jibo, take the picture.
He's a hands-free helper. You can talk to him, and he'll talk to you back, so you don't have to skip a beat.
Excuse me, and?
Yes, Jibo.
Melissa just sent a reminder that she's picking you up in half an hour to go grocery shopping.
Thanks, Jibo.
He's an entertainer and educator. Through interactive applications, Jibo can teach.
Let me in, or else I'll blow your house in.
Hey, where'd you go? There you are.
He's the closest thing to a real-life teleportation device. He can turn and look at whoever you want with a simple tap of your finger.
Check out my turkey dinner, Mom.
I wish you wouldn't eat that.
Hey, they make turkey pizza? I want turkey pizza.
And he's a platform, so his skills keep expanding. He'll be able to connect to your home.
Welcome home, Eric.
Hey, buddy. Can you order some takeout for me?
Sure thing. Chinese, as usual?
You know me so well.
And even be a great wingman.
You have a voice message from Ashley. Want to hear it?
Absolutely.
Hey, call me when you're home.
Better make that takeout for two, Jibo.
We've dreamt of it for years, and now he's finally here. And he's not just an aluminum shell, nor is he just a 3-axis motor system. He's not even just a connected device. He's one of the family. Jibo, this little bot of mine.
What if technology actually treated you like a human being? What if technology helped you to feel closer to the ones you love? What if technology helped you like a partner, rather than simply being a tool? That's what Jibo's about. That's why I created this company. And I've got the right team to do it. People with a proven track record of bringing innovative technologies and exciting content to market. But now, we need your help to build Jibo, to bring it to the world, and to grow the community. Let's work together to make Jibo truly great. And together, we can humanize technology.
So that is the promise. As far as I know, Jibo is now on the market in the States since 2017. Well, the features are not really, well, from the reviews that I have read at least, they are not as good as potentially that Sirius and Alexa's can offer. But still interesting concept, I guess. Interesting concept about what we are expecting the technology to do to be part of our lives. This is the second. So basically, the point of these things, well, obviously robots are not all digital issues, but they make it more visible probably in comparison to other types of digital issues that we are interacting every day. but in some cases we are not noticing as well. So, it used to be humans and machines. Now, what we are witnessing is it's humans, machines, and something in between that we can't yet figure out what that is and what the dynamics are there for that space as well. So, yeah, I have got a couple of more examples. Basically, discussions around humans becoming data, providing biological labor, being professional data sellers, probably. I don't know how to describe. There's a new site on, for example, on whether chatbots have something to do with suicide prevention. I can't imagine what the ethical consequences might be if in those sort of situations. We have got people sort of trying to fake the whole system and obviously giving us in basically that case in the last one on top floor we have got basically a fake restaurant getting top ratings on TripAdvisor. That happened a couple of years ago. It's a London restaurant, fake restaurant. They have got face recognition used in everyday operations in London as well. And we have got, in this case, in the middle, we have got actually DNA. Sort of, there's an attempt to use DNA to shame for publicly shaming people who doesn't show the right behavior. So in this case, as far as I remember, it's the cigarette remains that were collected on the streets and then analyzed, and these are the faces of people that they think might have thrown those cigarettes out there, cigarette remains there. We have got Ancestry, Spotify collaboration, basically giving you options based on your racial background, Ancestry, and again systems that are designed to fake the whole system. So we have got some formal frameworks appearing since long time. Well, it depends, probably relatively long time. So we had Asimov's 1950, the 3 laws of robotics to start with. More recently, we have general data GDPR clearly introduced a lot of discussion. And more recently, it is to do, in the UK, we have UK's online safety laws white paper just launched recently. In the US, there is this conversation around Algorithmic Accountability Act, etc. So these are coming up, but from a system design and engineering point, it's all really nice to come up with frameworks. What it means in terms of technology, it's a very different issue, clearly. If as a system designer, we think that since we have divided into 3 subcategories, data, algorithms, and interactions, we think that actually systematically you can look into issues in parts. In the data process, for example, it's the collection of which data you collect, where do you store it, and then how do you allow access, how do you transact that data. In the algorithms, what we are feeding into the algorithms and how we define the process itself and the outcomes as well, outcomes and functionality, the results that what we do. And in the interactions, I have a list of different surveillance, autonomous systems, so different functions that I thought that would go in here, but it's obviously list can be extended. And we have to, again, realize that there is always interactions between these 3 components. So it's, we can look at things in isolation, but at the same time, we have to look at them as part of a whole system as well. So just a series of case studies now. Sentencing criminals, important life events. So in the US especially, it is a widespread thing to use risk assessment tools to basically predict criminals to be the risk of criminals to be reoffending. And there's this textbook case where in 2013, basically someone was prescribed an 11-year sentence with 6 years in prison for crimes that do not themselves require any prison time. And later, basically in that decision, Compass's high risk of recidivism prediction was cited amongst all the other reasons, basically all the other factors. And later, what happened was another study showed that this Compass algorithm is actually discriminating against, discriminating racially, basically. It's giving double twice the higher risk of recidivism for black people than it actually is, and half the risk of recidivism for white people than it actually is. So it sparked some public conversation, obviously, about what are the problems with machine learning type of algorithms in these sort of situations. A clear discussion, obviously, is that those who are supposed to deliver justice, lawyers, judges, or other people, they don't necessarily have really insight into these sort of algorithms, even if they were given. And in the Compass case, Compass was a commercial, a proprietary algorithm, so they did not have that access anyway. And people who write those sort of algorithms, people who design those algorithms, are not necessarily really capable of delivering justice either. So there is this huge issue. But bias is becoming more and more obvious, and algorithms normally lean into the assumed correctness of whatever the initial assumptions were at the initial setting of the algorithm. And there is also the issue that coming up with discrete type of reasoning or unidirectional reasoning is not really the wise thing to do in many criminal cases, probably. So the algorithm can't basically think of potentially thinking about, like, if you sentence someone more, then you are actually contributing to the risk of recidivism in the future as well. So there might be other parameters that maybe a human judge could take into account, but these algorithms are not yet there. But we have to also recognize that if these algorithms were a bit more transparent and accountable, if we could sort out the transparency and accountability issues, then they actually do have a big role to play in the criminal justice system. So for accountability, I have got Microsoft's Tay, another big textbook case. Basically, what happened, for those who are not familiar with the application, with the experiment, Microsoft launched this Tay as a sort of Tay was supposed to behave like a 19-year-old American girl on Twitter and learn from interactions with the Twitter users. What happened was, as soon as it was launched, in a couple of hours, it started tweeting racist, neo-Nazi, sort of sexually charged tweets. And within 16 hours, Microsoft had to take it down, basically, in the end. And I have a paragraph here from the statement that corporate vice president Peter Lee put up the next day, as far as I know. Basically, it essentially says that they have planned and implemented a lot of filtering, conducted extensive user studies with diverse user groups, stress tested Tay under a variety of conditions, specifically to make interactions with Tay a positive experience. And once we got comfortable with how Tay was interacting with the users, we wanted to invite a broader group of people to engage with her. Unfortunately, in the first 24 hours of coming online, a coordinated attack by a subset of people exploited a vulnerability in Tay. Although we had prepared for many types of abuses of the system, we had made a critical oversight for this specific attack. So basically, it is. I mean, I think it at least demonstrate how difficult it is to identify what the problem was when these algorithms start going wrong. And in the worst case, basically, as these algorithms become more and more sort of part of our lives, the consequences presents lots of legal challenges that we have to deal with. And the other famous example, driver's car, again, in an unavoidable crash situation. So how does the car's algorithm makes the decision on whose life to prioritize? Should it be the owner of the car, or should it be the maximum number of lives, or should it be a dog, or the person with pregnant person or pedestrian on the side? So, how does the algorithm, driverless cars algorithm makes these sort of decisions? And maybe, well, if we are going to ever have them on the streets, then how do we certify them? So, the other thing that I wanted to highlight is this East versus West chasm. Basically, what we are seeing is maybe I should start with the West actually. We have got Facebooks, Googles, Amazons, Netflix, having lots of data really about us, more informative knowledge maybe about citizens, ordinary citizens than the government has, and they have the capacity to link them and come up with interesting advantages basically for their own services. And the volume of their the research that are going on, I believe, like in Google's research capacity is much bigger than many of the universities, and it's not easy for the public sector basically to compete with something like that, or to regulate it actually. Well, even in the taxation case, it's not easy for the governments to find a solution on how they are going to regulate these sort of services in the first place. Although there's a big discussion, well, we have GDPR, we are discussing about how we are going to regulate algorithms, but I'm not sure really. I can't see that these are matching compatible situations. In the East, on the other side of the world, it is the government that has lots of access to lots of interest, lots of sensitive citizen data, and through things like social credit system, there's basically attempts to manipulate citizen behavior. Well, obviously that causes lots of other censorship type of issues as well, and in some cases actually using disinformation to deny some of the access to public services. So, and if we look at it, the population, well, it's not, I mean, the government-citizen relationship is not the same as what it is in the West, probably. We are talking about regulation a lot, but there it's not the case that much. And we also see that there's huge investments on that as well. I think one of the key questions for me is really how is this going to change the public discourse over time? Because the balance, we are sort of assuming here that Western values are going to be forever there, and we will try and regulate all these things. Well, we should recognize, I think, we should recognize first of all the vulnerability internally in the West against those big multinationals, growing capacity of them, and in the East, again, it's other type of interactions, and it is becoming dominant as well in the digital ecosystem. So, in terms of how we assess algorithms, so a nice sentence that I like for any situations is really, if all you have is a hammer, then everything looks like a nail. So that's supposed to be to demonstrate that's supposed to sort of spark the idea that the answer is not really in one discipline or in one sector itself. We have in the computer science field, we have a growing vocabulary of very relevant terms, starting with, well, most obvious ones are fairness, transparency, accountability. We have got, again, growing theories around robustness, reproducibility, legality, safety, is another obvious one. Interpretability of algorithms, etc., and some of the overlapping terms like bias, discrimination, and fairness, etc. It's not an easy task to drill down into what is happening in the algorithmic design stage. I again have the inputs and definitions, how we put what we are feeding into the algorithm as a like overall a list of inputs that are going into the algorithm, and depending on the process, again, if it's a knowledge-based system or a machine learning system, you have different parameters there as well. And the outcomes, definition of outcomes is one thing, and trying to get the outcomes you want is one thing. There is also this unintended outcomes, which are like privacy breaches, for example. Even if you try to anonymize data that is going into the system, still after analysis, it's very very likely that the information can be estimated, recovered from other like secondary information that you thought you anonymized in the first place. So if you're trying to when we talk about having insight into algorithmic behavior, there are different approaches, and the first one is looking at the outcomes basically and trying to make the system accountable, which is you need to test, you need to train your algorithm constantly, because you don't have actually insight into the process itself, and you have to really watch for edge cases, especially because these algorithms really need to tend to discriminate against outliers in particular. So this is a nice this is using is a I think very sort of popular example. I just put it for fun. Basically, if you are making decision based on what computer's saying, so if you have applied for a loan and you don't get it, if the computer says no, then that's it. Basically, you don't know what you can do about that. A second way to look into finding some insight into algorithmic behavior is where algorithm tries to explain itself a little bit more, so it gives us some sort of reasoning. In this example, for example, the first picture, the question asked is, what sport is this? The answer is baseball, and the textual justification that the algorithm gives is the player is holding a bat, basically, and similar in the lower column. So in a loan situation, again, for example, your loan application has been rejected, but you are given some sort of explanation like your loan application has been rejected because you haven't paid your last 3 rents, for example. But if you keep paying them in time over the next 5 months, maybe, then if you have that sort of information, the idea is that you can actually intervene to the process and improve the situation. But that's not really understanding how the algorithm works, or it's not really explaining the algorithm itself. In GDPR terms, what is understanding algorithm? What that concept includes is a full understanding of, it says that basically statistical models should be appropriate, which is not an easy task again. So if it's a linear regression case, so if you're trying to find the line that separates, that classifies 2 types of data points, then that's okay, you can deal with that. But if it is it's not always that easy. The relationships are often very complex, and statistical clarity is far away right now. Here, basically, just going on. So in terms of Adriano and I when we were thinking about, we sort of came up with some building blocks of what we think we should think through about these sorts of situations. So, we are in a computer science department. Obviously, we start with mathematical formulations and then technology solutions, and potentially offering some technology, again, to regulate those technologies as well. But obviously, it starts it has to start from the very top at the principles and values level. And we have policies. In a social science environment, it's the policies and laws and codes of conduct that makes more sort of matter. So we have got basically 5 levels that we look into a problem. We think we should look into these sort of problems. So starting with, if we take the issue of fairness as an example, so it really, you can refer back to big sort of universal, in this case I have got the Universal UN Declaration of Human Rights, Article 1 as a starting point, which states basically all human beings are born free and equal in dignity and rights. Great. But how do we satisfy this in technology terms? We'll get there, hopefully. So when we go a little bit one step further, it's the policy and law codes of conduct. So in legal terms, law basically tries to model these principles in using words into turning them into articles. So it's basically in the U.S. case, Civil Rights Act of 1964 basically states that it shall be an unlawful employment practice for an employer to fail or refuse to hire or to discharge any individual or otherwise to discriminate against any individual with respect to his compensation, terms, conditions, or privileges of employment because of such individual's race, color, religion, sex, or national origin. Okay, a little bit more clearer than the previous slide. And the uniform guidelines of employee selection procedures, basically it goes a little bit one more step further and tries to describe what they mean by this discrimination. How do they basically describe discrimination against a certain group, which has the 80% rule in the case. So if any of the comparison groups do not have a passing rate equal to or greater than 80% of the passing rate of the highest group, then it is generally considered as evidence of adverse impact. So when we come to maths and technical formulation, it's more symbols and abstractions now. So I have got some of the most basic definitions. Basically start with, A is a set of protected attributes. So in this case, for example, it could be gender, race, disability factors, etc. X is all the observable attributes of any particular individual, so all parameters, all attributes that you have in your data. Y is the outcome, so it is sort of if a person gets the job or not, basically, and Y hat is the predictor. So we have got different definitions. One of the two of the most common ones are in the individual fairness case, for example. It states basically the algorithm is fair if it gives similar predictions to similar individuals. So you are formally defining a metric, and your individuals are now I's and J's. And if your metric for these two individuals gives you a small, if it is small enough, then the prediction, you expect the predictions to be similar as well. So that's so outcomes for similar people should be similar, basically. In another definition is at the population level, something that's called demographic parity in this situation. So basically it says that a predictor Y satisfies demographic parity if the distribution of the predictor is the same regardless of what the value of the protected attribute. So in this case, basically, if we say that A is if the protected attribute is, say, female, and for female, if we have the 0 value, and for male, if it is the 1 value, we basically expect the distribution of the predictor to be the same for both values, for both attributes. The issue here is it sounds like a nice attempt, but we already have at least 20 different definitions of fairness, what algorithmic fairness mean, and and some of them actually theoretically, mathematically contradict to each other. The most basic case, most intuitive example is basically group level fairness does not necessarily mean it wouldn't ensure individual fairness, for example, or if it's individual fairness, then you can't ensure group fairness. So one more step down, basically, it's now the issue of fairness in technology terms. So if you're designing a whole system, you can identify and try to identify and address issues of fairness at the data level. For example, you can try to make your data more representative, or you try to deal with issues, any bias issues in your data at the pre-processing stage. You can do. There are techniques that looks into the algorithmic process itself, or how you construct the model itself. So I have a list of different discrimination discovery methods on here, and the list is obviously growing. And when it comes to creating a response or talking about compliance and regulation, well, my left column is not a long list because I'm not a regulator or a policymaker, so I don't know the actual sort of procedures, but it is more about, we are talking about policies, people, policies, and institutions. Well, the basic ones in the UK, we have Information Commissioner's Office trying to regulate these situations, or Financial Conduct Authority in the trading in finance. Our justice system is supposed to deal with some of these issues, and with GDPR type of regulations, we are basically, well, let's again, policy frameworks more specifically targeted at these sort of situations. But we think that actually, from a computer science point of view, we are more interested in potentially looking into what the technologies might be as a response to these issues. So we are considering, we are thinking through various options, like potentially creating reference data sets to check any bias in digital systems, potentially developing circuit breaker type of software to make sure safety and privacy. Well, stress testing came up earlier. And we sort of need to work on how we certify these sort of algorithms as well. And more generally, if we do more research on transparency, explainability of algorithms, and try to understand or try to develop systems actually that are accountable, or that is sort of more transparent in accountability terms, then these are the sorts of things that we are interested in the computer science department. Just in terms of these building blocks, but I was just going to say, we try to we think these are the main blocks that we should think through. But there is obviously, this is not a full framework at all. It's far away from that sort of position, especially given the fact that we don't have any feedback loops in this thinking. But I think, again, it illustrates some of the problems, that why we cannot align these different blocks with each other as well. Because what we see is, if we start with principles and go down to technology, it becomes arguments becomes more specific, it becomes more precise, more rigid, and it requires more and more technical literacy. And if we go the other way around, it's the generality, inclusivity, fluidity, and acceptability that increases. So makes the real life really hard to create an environment where lawyers can talk to engineers and then come up with a solution. It's not currently working that way. So just a couple of other things. Should algorithms be recognized as artificial persons, similar to companies in the legal systems? Well, I have heard judges discussing this, so it's in discussion whether we buy or not. It is offered as a solution. We have this lady robot as a legal citizen of Saudi Arabia. That another concept. there are discussions around robots' rights and obligations. So are we having them as our slaves? So is that another phase of slavery? Do we allow machine learning algorithms to police machine behavior? Maybe more acceptable, but how about human behavior? Or do we allow these machines to harm any human being? Which, well, the prompt answer would be no, but in a terrorism or in a war situations, we might hear people justify, well, actually it's in use as well already. There are technologies and discussions around those. But having said all these things, actually, I think this came up a few times in the conversation as well. Yes, we have got all these problems, but do we just stop inventing, or do we just really? There is also, we have to recognize also the cost of not innovating, not doing these things, not using data. And especially given the fact that if you don't do it, someone else will in another geography. These technologies are being developed as well, so we have to really try to balance our questions there too. So that's all from me.